Welcome, everyone. Today, we're tackling the cornerstone of long-term AI collaboration, project knowledge bases. If you've ever felt frustrated explaining your project's rules to Claude over and over, this session will change how you work. Let's get started. Let's start by defining what a project knowledge base actually is. In short, it is a persistent collection of instructions and context that Claude loads before it even looks at your current prompt. The basics revolve around providing a stable environment. In Claude Code, we use files like claude.md, and in the web interface, we use projects. Why is this so crucial? Because as developers, we know that repeating instructions is a massive waste of time. Without persistent knowledge, AI suffers from context amnesia, leading to repetitive mistakes. How do we fix it? We supply foundational documents that ground the AI. Our deep dive reveals that modern agents use a multi-layered memory system, meaning they process your project's entire architecture and rule set before executing a single task. Take a look at this flowchart. Traditionally, a user prompt goes straight to the AI. But here, the context engine acts as a gatekeeper. It pulls your persistent project knowledge base and merges it with your prompt. Claude processes this combined payload, guaranteeing a context-aware output that strictly adheres to your project's unique guidelines. To build an effective knowledge base, you must understand Claude's memory hierarchy. What is it? It's the structured priority system Claude uses to resolve conflicting rules. The basics are broken down into levels: managed policy for the entire organization, user memory for your personal habits, project memory for the specific codebase, and auto memory. Why use a hierarchy? Because an IT team needs to enforce non-negotiable security standards, but you still need your personal shortcuts. How it works is simple. Claude reads these files from the top down, with higher-level organizational policies overriding local project rules. The deep dive here is auto memory. This is an incredible feature where Claude actually observes your corrections during a session and writes notes to itself for the future, preserving up to 25 kilobytes of organic, learned context without you lifting a finger. This top-down diagram illustrates the memory hierarchy in action. At the very top, in red, is the managed policy, which dictates strict organization-wide rules. This flows down into user memory, then into the green project memory. It gets more granular with path-specific rules, and finally bottoms out at auto memory, where the AI dynamically stores its own learnings. Higher boxes always overrule lower boxes if a conflict occurs. Now, let's get hands-on with crafting the perfect Claude.md file. What is it? It's the central nervous system for your project's context. The basics involve filling this markdown file with your specific build commands, testing frameworks, and architectural rules. We do this because we never want Claude guessing how to compile our app. How do you write a good one? You must keep it concise, ideally under 200 lines. Use strict bullet points and completely avoid generic fluff like write good code. Look at the sample code on the slide. It explicitly tells the AI exactly what commands to use. Our deep dive reveals a powerful scaling technique. Claude.md supports recursive file imports. By using the @ symbol, you can import other markdown files up to 5 layers deep, allowing you to modularize a massive enterprise knowledge base into clean, manageable pieces. This diagram shows how to modularize your knowledge base using import syntax. Instead of one massive, unreadable file, our root Claude.md cleanly imports separate markdown files for front-end, back-end, and database rules. This modular architecture keeps your token usage efficient and your instructions highly organized. If you are using the Claude API or Agent SDK, you have access to an incredible feature, the memory tool. What is it? It's a capability that allows Claude to persistently store, read, update, and delete information across entirely different conversations. The basics involve Claude accessing a dedicated file directory to maintain running state documents, like a project checklist. Why is this a game changer? Because it completely eliminates the need to manually bring Claude up to speed on your project's status every time you start a new chat. How does it work? Claude is equipped with tool commands like create, view, and strreplace, allowing it to actively edit its own memory files in real time. The deep dive benefit here is context optimization. Instead of shoving 50 pages of history into the context window, Claude selectively pulls only the exact memory files it needs for the task at hand. Look at the sequence diagram mapping Claude's autonomous thought process. First, Claude calls the memory tool to view the progress markdown file. The file system returns the pending tasks. After Claude completes the work, it autonomously calls strreplace to update the task status from pending to done. The AI is managing its own project state without human intervention. As your project grows, your knowledge base will too. This brings us to scaling knowledge using rules and skills. What are they? They are advanced organization methods that inject context only when it's absolutely necessary. The basics, path-specific rules trigger based on the file type Claude is looking at, and skills provide on-demand workflows. Why do we need this? Because shoving every rule into the root Claude.md wastes tokens and degrades Claude's focus. How do you implement it? You create a rule file with a YAML header targeting a specific path, like src/components/.tsx. Now, those instructions only load when Claude touches your React components. Our deep dive highlights the concept of progressive disclosure. Claude only reads the lightweight descriptions of your skills at startup. It only injects the heavy, token-dense payloads when a specific task specifically demands it, keeping your AI lightning fast. This decision tree shows how conditional context routing works. When Claude prepares to edit a file, the system asks, does this file path match a specific rule? If yes, it dynamically injects that specific rule file into the prompt. If no, it relies purely on the standard Claude.md. Both paths lead to an optimized execution that preserves your context window. If you are injecting massive amounts of project knowledge, you must understand prompt caching. What is it? It's an API feature that stores and reuses your large knowledge base across multiple requests. The basics are staggering. By setting a cache breakpoint, subsequent queries against your knowledge base cost 90% less and process almost instantly. Why is this mandatory for enterprises? Because repeatedly sending a massive knowledge base per conversational turn will destroy your budget and increase latency. How do you do it? You structure your prompt so that your massive project memory files and tool definitions sit at the very top. You place a cache breakpoint there and append the dynamic user messages below it. Our deep dive shows that caching relies on exact prefix matching. As long as your foundational knowledge base doesn't change, every single interaction hits the cache, supercharging your agentic workflows. Look at the API request payload in this flowchart. We place the heavy, static system rules and Claude.md at the top, immediately followed by the cache breakpoint. Because this massive chunk of data is cached, it results in an instant cache hit and a 90% cost reduction. Only the tiny, dynamic user message at the bottom actually costs full processing power. Let's bring this to life with a real-time use case, multi-session software development. Imagine your team is building a complex application over several weeks. The problem with traditional AI is that tomorrow, it forgets the architecture decisions you made today. Here is how we fix it. Step 1. The initializer session. The team establishes a Claude.md file outlining the tech stack. Claude then uses the memory tool to generate a progress.md file. Step 2. Subsequent sessions. It's Tuesday morning. You open a brand new empty chat. Claude immediately reads the Claude.md and the progress file, recovering the exact state of the project in milliseconds. Step 3. End of session update. At 5 p.m., before logging off, Claude autonomously updates the progress log. You've just achieved continuous, asynchronous AI collaboration that spans weeks without a single loss of context. This state diagram maps the continuous development loop. We begin with the initializer session, which creates our progress log. The session closes. When the new session starts tomorrow, the very first action is to read the progress log, instantly restoring state. We execute development and, crucially, update the progress log before closing again. It's an infinite loop of preserved knowledge. To wrap up, maintaining your project knowledge base requires discipline. First, audit regularly. Treat your Claude.md file like production code, prune outdated rules, and test your changes. Second, avoid context rot. If you have automation scripts writing to your memory files, ensure they check for duplicates before appending, otherwise the file grows infinitely. Third, be ruthlessly specific. Delete vague advice like write clean code and replace it with testable rules like always use explicit return types in TypeScript. Finally, leverage subagents for heavy research. If you need to read a massive external API doc, spawn a subagent. It will process the heavy context in isolation and return only the summary, keeping your main knowledge base pristine. Master these skills, and Claude becomes a deeply integrated senior engineer. I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you next time. Our final diagram distills knowledge base management into 4 pillars: audit regularly, avoid context rot, write specific rules, and use subagents for heavy context. By rigorously applying these 4 practices, you guarantee the outcome on the right, a high-performance AI team member that scales perfectly with your enterprise.